This is a quick video on section 3.3 related to the product rule formula. Where does the formula essentially come from for the product rule? That is, how does one take the derivative of two functions multiplied by each other? How should one do that? Okay, that's a big question. I mean, you have some guesses. Maybe a guess would be that the derivative of two functions being multiplied by each other. You could guess that that's equal to the derivative of one of the functions, the derivative of the other function, and then you just simply multiply those two answers. And here you would be thinking, well, that's the way we do it for the derivative of two functions added to each other. We knew that the derivative of two functions added to each other was f prime plus g prime. Okay. But did it work the same way for multiplication? That would be your guess. And so we'll see how to approach this problem and fill in the formula. Okay. So just a quick reminder, always good to recall certain simple examples, and those simple examples can usually lead you in the right direction of remembering some stuff. So take a look at f of x is equal to x squared. Okay? We'll remember that when we were computing the derivative, it was necessary to look at f of x plus h. Okay? X plus h, and then you had to square it. This was the key first step. Okay, the key first step was there. And when you did f of x plus h, and you, for this example, have to square that out, you'll get x squared plus 2x times h plus h squared. And now, quick observation, notice that when you did f of x plus h, you got the function f of x back again, okay, plus, and from the power rule, we recognize the 2x there as f prime of x multiplied by h. And then there was stuff higher degree in h, like the h squared, h cubed, h to the fourth stuff. Right? But what we're essentially seeing here is that f of x plus h is approximately the function evaluated at x plus a little bit more, plus the derivative times a little bit h. So what we're seeing here is, observe that f prime of x, the derivative, is the term in front of the h. Okay? So if you have some function f of x, and you can find f of x plus h, then f of x plus h is approximately going to be f of x plus f prime of x times h, where f prime is the derivative function of f of x. Okay? Now, the same goes for a function g of x. If you want to find the derivative of g of x, you could put in g of x plus h, possibly, and that g of x plus h is going to be approximately the function itself, g of x, plus a little bit more, and that little bit more, it comes from the derivative of the function g multiplied by h. So these are what we know, okay? So if you want to find the derivatives of f and g, might be a good idea to think about putting in f of x plus h and g of x plus h. So if you're given a function, then you could do this process to kind of like find the derivative. Do the expansion g of x plus h and look for the term in front of the h. And this works for polynomials particularly. Okay. So now here's the new idea. What if you want to, the function given to you is f of x times g of x. Okay. then it might be a good idea to put in fx plus h in for everywhere you see the x, I'm sorry. Okay. But we know that f of x plus h is approximately f of x plus f prime of x times h. And we know that g of x plus h is approximately g of x plus g prime of x times h. Okay? And now if you FOIL this out, you'll get f of x times g of x plus f of x times g prime of x times h plus f prime of x g of x times h plus f prime of x times g prime of x times h squared. You're just FOILing this out. And remember, right, that when we did the f of x plus h times g of x, you got the function back again, f of x times g, and then the derivative of f times g, the derivative of f of x times g of x is the term in front of the h. And there are two h terms here, so you could factor out the h, and you get f g prime plus f prime g, which says that the derivative of a function f of x times g of x, the correct formula, is the first function times the derivative of the second plus the second function times the derivative of the first. It's just FOIL and using the idea that the function f of x plus h can be approximated by f of x plus f prime of x times h, or this is the estimate of f of x plus h. And then you just use FOIL and you get the formula for the product rule. And so ends this video.